Hi everyone, it's Miss Costa here, and in this video we're going to go through some of the statistics, graphs and charts for your end of year revision. So all of the subtopics are here in the table, and tick them off when you feel confident. Okay, so the first thing we're going to do is drawing pie charts. So in this question I'm told that 40 students pick their favourite sport and their data is shown in the frequency table. And now I need to draw a pie chart to show this data. So frequency just means how many, so the amount. So this question is referring to students. So where it says the frequency, that's telling me how many students. So 18 students like ice skating the most, 12 students like rock climbing the most, and 10 students prefer Muay Thai. So what I need to do first, I know that in a pie chart, angles sum to 360. Okay, so if I split this pie chart, all of these angles here, we're going to sum and add up to make 360 degrees. I know that this pie chart is split into 40 students. So when I'm drawing the first chart, the first thing I do is 360 divided by the frequency to figure out how many degrees one person would take up. Because I'm essentially splitting this pie chart 360 into 40 different equal parts, and then I'm going to shade however many parts are for each sport. Okay, so if I did 360 divided by 40, and this was non-calculator, what I'd do is I'd first simplify my fraction. So I divide by 10, so that's the same as 36 over 4, and 36 divided by 4 is 9. So I know that one student takes up 9 degrees on the pie chart. So when I know that, I can figure out how many 18 students would take, and that would be 18 times by 9. This would be 12 times by 9, and that would be 10 times by 9. So the total amount of degrees that 18 students take up, what can I do? Well, if this was non-calculator, I've got 18 times 9. I'd just have to do the normal multiplication method. There is no little trick for this. So 18 times by 9, I do 9 times by 8, which is 72, and 9 times by 1, which is 9, and add the 7. So that's going to be 162 degrees. 12 times 9, you might know your 9 times table, so 10 times 9 is 90, so add on 2 lots. But if not, then we do 9 times 2, which is 18, 9 times 1, which is 9, add the 1 is 108. And the final bit is 10 times 9, which is 90 degrees. Now to double check if you've done it right, 162 plus 108 plus 90 should add up to 360. If all of your angles you've worked out add up to 360, the likelihood is if you've done that right. So the next thing we do is to actually draw this on our pie chart. Now the first degree that I'm going to do is 90 degrees for Muay Thai, because that's really easy. That's just going to be a right angle. So I'm going to draw that here. I'm going to label it as 90 degrees, and then I'm going to write inside what that represents. So that's Muay Thai. Then I'm going to do 108 degrees. So you get your protractor, you line it up, and then you measure it out. So 108 degrees would be over here. So I would label that 108 degrees, and I'd say that's for rock climbing. And then the last one would be 162 degrees, and that's going to make up the rest of the pie chart. So 162 degrees is ice skating. Now, if you were asked questions about a pie chart, you say, for instance, what is the mode? The mode is the most common. So the most common or the most popular sport is ice skating. But that's how we do drawing a pie chart. The most important thing is that you do 360 divided by the total frequency, and that tells you how much one student is, or it might be a car, it might be a person, whatever it is. You do 360 divided by the total frequency, and that tells you how much one person or one unit is. Okay, next we've got averages from a table. So in this question, the table shows the number of times students check their phone in an hour while watching TV. And I'm asked, what is the modal number of times someone checks their phone? So modal is just the plural of mode, and that means the mode is the most common. So mode is the most common. And actually, let's write that here. So mode is the most common. So the modal number of times is going to be the most amount of times. So what I do is I look in the frequency column, because that tells me how many times the students have been checking their phone. The highest number is 8. So that means that 8 people check their phone 3 times. So the modal number of times someone checks their phone is 3 times. But actually what I'm going to do is show you what this data actually represents, so that you can, if you get really stuck, this is your fallback method. So 3 people check their phone 0 times. So that means there's 3 lots of zeros in my data set. 4 people check their phone once, so that's 1, 1, 1. 2 people check their phone twice. 8 people check their phone 3 times. So I've got 1, 2, 3, 4, 5, 6, 7, 8. And 3 people check their phone 4 times. So I've got 1, 2, 3 lots of 4. So sometimes if the data on the table confuses you, you can just write it out like this, like the data set, and then work out the mode from there. So the mode is the most common. So we can see that 3 appears the most amount of times. And that's why that's the modal number of times. Now the range, this one is a little bit trickier. So the range is going to be from the number of times. So people can check their phone between 0 and 4 times. So the range is 4 times. And this is where it gets a bit confusing, because you're like, which column do I do? But think about what the data is doing. And if you get stuck, write out the data like this. And you know that the range is the largest value, take away the smallest value. So that's why it's 4 times. And then this is the trickiest bit. Work out the mean number of times students check their phone. So if you can see, this is what the data looks like. So what would I do if I was working out the mean of this data set? I would add all the values together and divide by how many values there are. So I'm going to show you why you can do this from a table. But what we would do if we were doing the mean normally, we would do 0 plus 0 plus 0. Actually, I'm just going to do it here. So add all of these values together and then divide by how many numbers there are. That's how we work out the mean. We add all the values together and we divide by the number of values there are. So let's count how many numbers there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 in total. So I know I'm going to be dividing by 20. And now all I need to do is work out the sum. So I can add it up individually, or because I know that repeated addition is the same as multiplication, I can use a shortcut. So my shortcut would tell me the total frequency, or the total amount of times it's been picked up. So 3 people pick their phone up 0 times. So 3 times 0 is 0. Okay. Here I could add 4 times, or I could just do 4 times 1, which is 4. Here I could have done 2 plus 2, or 2 times 2, which is 2. Then this is where it gets a bit better to do it the table method. 3 times 8 is 24, or 3 added together 8 times is also 24. And then 4 times 3 is 12, and 4 added together 3 times is also 12. So you choose which way works best for you. If you're adding them together, that's fine. But you could also do the frequency method with the table, and it's good to get into that habit, because when the data sets get really large, that's when it's going to be helpful. So I add my sums together. So I'm going to do 0 plus 4 plus 24 plus 2 plus 12. So let's simplify it as much as I can. 4 plus 2 is 6. 6 plus 12 is 18. So then I could just do 24 plus 18. And 8 plus 4 is 12. 2 plus 1 is 4. So that would be 42 is what all of my data adds up to. So I do 42 divided by 20. And if it's non-calculator, I could simplify that to 4.2 divided by 2, I've just divided by 10, and 4.2 divided by 2 is 2.1 times. So this is slightly trickier, especially mean. Mean is very tricky to do, but you've got two methods, either the table method where you multiply the frequency times by the number of times, add it together and divide by the total frequency, or write the values up and work out the mean as you normally would with a data set. So if you're feeling super unconfident about tables, try the second way. Okay, next we've got two-way tables. So two-way tables are really fun. They're just like filling in the missing things, being a detective and finding the missing numbers. So I'm given some bits of information and I need to work out the other bits. And all I'm going to do is either add or subtract to get my totals. So this is the information I've been given. I know that there is a total of 80 girls and a total of 90 boys. So there's 90 boys and 80 girls. All I need to do is add them together and that will give me the total amount of people. So that's 170. And that's the first piece of information that I can fill out. Next, I'm going to look for just one gap in either a row or a column. So over here, I know 32 girls like French, 35 girls chose Spanish, and there's a missing number here. But I know that 32 plus 35 plus the question mark must equal 80. So what I'm going to do is add 32 plus 35. And actually, maybe we can use a calculator for this just to speed it up. So 32 plus 35 is 67. So I know that 80 take away 67 is going to give me this missing number here. So 80 take away 67 is going to give me 13. Now to double check if you're right, you would do 32 plus 35 plus 13 and it should make 80. So all your rows and all your columns always need to add up to the total. What's the next bit that I could work out? Well, over here, I know that I just have to add these two numbers together because this is a total. So 13 plus 12 is 25. And now I filled out another piece of information. So here I know that 70 plus this plus 25 must equal 170. So I'm going to do 170 take away 95 because 70 plus 25 makes 95. And 170 take away 95 is 75. So I've worked out another piece of information. What can I work out next? Well, here I should notice that there's a little gap. So I know that 75 take away 35 is going to give me this missing piece of information here. So that's 40 boys that like Spanish. And then the last bit is this piece here. So I know that something plus 40 plus 12 must equal 90. So I'm going to do 90 take away 52 because 40 plus 12 makes 52. And 90 take away 52 is 38. So now I have completed my two-way table. And all you're doing is you're trying to figure out what the totals are for each column and then using them to subtract to find out the other missing values. And now I just need to read from the two-way table. So how many girls study German? So let's have a look. Girls is this row here and German is over here. So where do they intersect? In this box here. So that's 13. Okay, so that's how we read a two-way table. Next it says how many boys study French or Spanish. So boys, I'm going to go in this column here. French is 38 and Spanish is 40, and 38 plus 40 is 78. And then it says, what is the probability that a girl studies German? So probability is always out of a total. So how many girls are there? There's 80 girls. So my total is going to be out of 80. And how many like German? Well, that's 13. So my probability would be 13 out of 80. And then what is the most popular language to study? So I'm going to look in my totals here. So 70 people like French, 75 like Spanish, and 25 like German. So 75 is the highest value. So therefore, Spanish must be the most popular language to study. Okay, so in this question, we're dealing with a grouped frequency table. Now, the difference between this and the table we looked at before is that everything has been grouped into bunches. So instead of each thing having its own column, so me saying 421, 422, 423, that would take forever because my lowest value is, let's say, 402. and my largest value is 630. So I'd have over 200 columns in my table. That's a lot of columns. I don't want to do that. So instead, I'm just going to say I want all the data between 400 and 500. Now, it's important to pay attention to the inequality here. So all this means, when it's got a little line underneath it, it means it's less than or equal to. And when it's got this with nothing underneath, that just means less than. So what this group interval is telling me is I want to put all the puppies whose weight is 400, either 400 or greater, but less than 450. So it can't actually be 450. So Amirali's dog had some puppies, and he recorded the masses, M, of the puppies when they were born. And I need to complete the grouped frequency table. So the first thing I'm going to do is look for all the puppies that had a weight between 400 and less than 450. So 421 fits in that. 450, no, because that will be in the next one. And then 402. So that is 2 puppies. So it's good to keep a tally and then put the frequency in, just so that it reduces your working memory. Next, I've got between 450 and 500. So that's 450 is 1. 501 would go in the next one. 450 and 500, that's it. So that's just 1 puppy. Then we've got between 500 and 550. So 501, 549, that's 2. 512, that's 3. And that's all I've got there. Then between 550 and 600, so 557 and 570, that's 2. And then the last bit between 600 and 650, that's 1, 2, 3, 4. So the way I can double check if I've counted all my values, how many values are there in total? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 puppies. So my frequency is going to need to add up to 12. Is that true? 2 plus 1 is 3, plus 3 is 6, 7, 8, 9, 10, 11, 12. Yes, so I know I've done it right. So I've completed the grouped frequency table. Now, what is the modal class? Remember, modal is just the plural for mode. So I'm looking for the class that has the highest frequency, and that would be 4. So 4 puppies were between 600 and 650. So when they're asking for the modal class, you write out the whole class as it is in its inequality. What is the width of each class? So that means what's the difference in weights? So you go between 400 and 450. So we're going to say it's 50 grams. What is the range of the weights of the puppies? So basically, what is the range of their weights? And to do that, we're going to need to find, well, this is a bit of a nasty question, because if it was using the grouped frequency table, we'd say, well, the highest value it could be is 650, the lowest is 400, so the range would be 250. But because I've got the data, you're going to use the raw data. So the largest value is 630, and the smallest value is 402. So 630 take away 402. Remember, the range is the difference between the highest value, the largest value, and the smallest. So we do that. So 10 take away 2 is 8, 2 take away 0 is 2. So it's going to be 228 grams, and that's the real range. If they're asking just for the table range, it would have been 250 grams. So imagine you didn't have any of this data and you just had the table. That's when you'd use the table. And what is the mean weight of the puppies? Now, this is a really long, difficult question. So if you remember with the last question, we wrote out all of the data. So actually, there's 2 ways you can do this. You could add all of these values together and then divide by 12. And because they've given you the data, that's absolutely fine. What I'm going to show you is how to do it if you haven't been given the data. So if you haven't been given the data and you've just been given the table, what you do is you create a few extra columns for yourself. And what we're going to do, because we're estimating the mean weight, is we're going to work out what the midpoint of the class interval is. So the midpoint is the middle. The way you do it technically is you'd add the two things together and divide by 2. But, so that would be 850 divided by 2, which would be 425. But with this one, we can actually just probably kind of look at it and figure out, okay, halfway between 50 is 25. So the midpoint would be 425. So first thing we do for the mean from a grouped frequency table is do that. So that would be 475 here, 525, 575, and then 625. And what I do is I do the midpoint times by the frequency. So I multiply these numbers together. And this would be a calculator question. So 425 times 2, 425 times 2 is 850. 475 times 1 is just itself. 525 times 3 is 1,575. 2 times 575 is 1,150. And 4 times 625 is 2,500. And what we do is we add the midpoint times frequency column. So we add all of this together and we divide by the total frequency. So we know that that's going to be 12. So we add all these values together. So 850 plus 475 plus 1575 plus 1150 plus 2,500 is 6,550 divided by 12 is going to give me 545.83 recurring. So that is how we'd work out the grouped, the mean if we weren't given this data here. But because you've been given the raw data, you can work out the exact mean by adding them all together and dividing by 12. Hopefully I didn't overcomplicate it. I just want you to know what you'd do if you weren't given the data. But if you do have the data, the easiest thing is to do, add all the values together and divide by how many numbers there are. Okay, so in this question, I'm told that Lily is going to send some parcels. So here are the weights of some of the parcels that Lily has to send. It's 4.2, 6.1, 5.4, and they're all in kilograms. And I need to construct a stem and leaf diagram for this data. So a stem and leaf diagram is something that looks like this. And what I do first is I create my key. So my key tells me what everything means. So let's start with the first value, 4.2. So 4 and then 2. What I'm going to do is I'm going to use my branch line to represent the decimal. So 4.2 actually means 4.2. So the second thing I do is I look at my smallest value. So what's my smallest value is 3.2 and my largest value is 6.8. So I know that I'm going to start with a 3 and I need to go to 6. So maybe I've made that too small. Let's try again. So I'm going to need to start with 3, 4, 5, 6. So 3, 4, 5, 6. And I don't think I have any larger data than that. Okay, so what I'm doing is I'm separating my data like this. Now you might want to just do a rough stem and leaf diagram. So I'm just going to do a rough one because it always helps before you organize it. So here's my rough stem and leaf diagram. And what I'm going to do with that is I'm going to put all of the data in it, but it's not going to be ordered. When you do your final stem and leaf diagram, you want it to be ordered. So I'm going to tick off each piece of data one by one. So 4.2 is going to be here. 6.1 I'm going to put here. 5.4 I'm going to put here. 6.8, when you get to another term, you put a comma to show it. Then we've got 4.5, 5.7, 3.2, 3.8, 4.5, another 4.5, 5.2, and 6.0. Then I'm going to double check I have the right amount. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got the right amount of values. And now I'm going to put them in order. So for 3, I've got 3.2 and 3.8. So I'm going to do 2 and 8 because that's an ascending order. Then I've got, okay, well, they happen to be in order for 4 as well. So 4.2, 4.5 and 4.5. And then I'm going to put 5.2, 4 and 7. And for 6, it will be 0, 1 and 8. Some people think that if it's 0.0, you don't need to include it, but you do. Every value has to be included. So that is my stem and leaf diagram. I'm literally ordering the data. And I've decided that it's because it's like in kilograms and it's points, that with my key, this is the stem, this is the leaf. So that is going to represent the whole number, and this is going to represent the decimal. So that's why that means 4.2. Similarly, if I had 5 and 8, that would mean 5.8, and that's how I'm representing it. Now, what is the median weight of the parcels? So the median is the middle number. So there's 2 ways I can do this. Either I can count, or I know there are 12 parcels, and to work out the median, I do the total plus 1 divided by 2. That would be 13 divided by 2, which tells me the 6.5th value is the median, which basically means I need to work out what's in between 6 and 7. Okay, so I'll show you the other way you can do it, which is just a crossing out method. So I cross 1 from the front, 1 from the end, another from the front, another 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 from the end. And then I'm left with 2 values. So this is actually what the 6.5th value means. So I'm left between 4.5 and 5.2. So what I need to do is work out the median, the middle of those. And the way you work out the median is you add the values together and you divide by 2. Whenever you're trying to work out the middle of anything, you add the 2 values together and you divide by 2. So 4.5 plus 5.2 gives me 9.7. So that would be 9.7 is what? Oh, I haven't divided by 2, sorry. 9.7 divided by 2, which, let's just make sure that's clear. 9.7 divided by 2 is 4.85. So the median is going to be 4.85. So this is a tricky question because there's 2 numbers in the middle. When there's 2 numbers in the middle, you add them together and divide by 2. The mode is the most common value. So remember, mode is most common. So I'm just going to look for the most common value, which in this case would be 4.5 because there's 3 lots of them. 1, 2, 3. No other number repeats itself. So the mode is the number that repeats itself the most. And the range of the parcel weights. So the largest value here I can see is 6.8. The smallest value is 3.2. So the range is just the difference between the highest value and the smallest value. So I'm going to do 6.8, take away 3.2, which is 3.6. So that's how I'd work out the range from a stem and leaf diagram. Okay, so here I am going to be dealing with what happens when I've got 2 sets of data and I want to compare them. So I'm told that here are the weights in grams of some tomatoes that Arinda and Martha planted. First thing I need to do is calculate the range of weights for Arinda and Martha's tomatoes. So the range for Arinda and the range for Martha. So Arinda's largest or heaviest tomato is 130 and the lightest tomato is 122. So that's going to be 130 take away 122, which is 8 grams. For Martha, the largest tomato is 144 and the lightest tomato is 102. So 144, so 44 take away 2 is 42 grams. So as you can see, if we think about Irinda's tomatoes and then Martha's tomatoes, all of Irinda's tomatoes are bunched here, 122, 130, whereas Martha's tomatoes start at lower and they end higher. So the weight that they could be is way more varied. Now, whose tomatoes were more consistent in weight? So it's your data is consistent when the range is smaller. So we would say that Irinda's tomatoes were more consistent as her range was smaller. So like it says at the bottom, a small range shows that the data is closer together and therefore is more consistent. And these are keywords that they love. Okay, so you need to use these kinds of words when describing the range. So when you're comparing data, you want to be comparing the range and the median. So a small range means it's consistent, it's bunched together. A large range means there's a big variety between the things that you're comparing, and therefore is less consistent. So now we're dealing with the median. So whose tomatoes had a higher median? So remember, the median is the middle value when they're all arranged in order of size. So let's just do that first. So we've got 122, 126, 127, 128, and then 130. And then with Irinda, we've got, oh, did I do them the other way around? Oh my gosh. Sorry, I wrote them the wrong way around. I thought Irinda came first. Oh, that's annoying. So Martha and Irinda. So it's Martha's tomatoes are way more consistent because her range is smaller. Okay, sorry about that. So we've got 102, then we've got 118, then 132, 138, and 144. Okay, so the median is the middle value. So cross, 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 cross the median for Martha. And we're going to do it the right way now. So Martha's median is 127, and Irinda's median is cross, 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 cross 132. So I'm going to say that Irinda's tomatoes were heavier overall as she had a higher median. Okay, so the way to compare the overall data is we generally look at the median, and the way to compare how consistent it is we look at the range. Okay, so here we've got some scatter graphs. Now, all a scatter graph is plotting two data sets against each other to see if they have a correlation. Now, a correlation just means, is there a relationship with them in terms of as one value goes up, does the other value also go up? Or as one value goes up, does the other go down? Or is there no relationship between them two? So for each graph, I need to describe the correlation shown and then use a sentence to describe the relationship. So I'm just going to quickly show you what the graphs are roughly. So if it's going down, and if you could draw a line of best fit and it looks like this, then it's a negative correlation. If they're all bunched up and there's no real pattern, there's no correlation. And if you drew a line and the data set's going up, then it's a positive correlation. So let's have a look at this graph here. If I drew a line of best fit, I can see that there's a clear negative correlation. Now the X and the Y axes tell me what's happening. So in this graph, I'm told that there's a time in seconds, and age in years. So I haven't been told the context of the graph, but I know as the age increases, the time in seconds decreases. Okay, so basically as my x-axis increases, the y-axis decreases, because look, here we've got, let's say, a 13-and-a-half-year-old takes 11 seconds to do something, whereas a 10-year-old would take 17 seconds. So the older you get, the quicker you do something. Now, let's look at the next graph. We've got roughly, if I were to draw a line of best fit, and a line of best fit, the way you draw it is you try and get as many data points above and below the line as you can. So what's this? Well, it's showing a positive correlation, which means a positive relationship between the maths test mark you get and the science test mark you get. So what's the relationship? The higher maths, okay, or let's do it in terms of relationship, in terms of going up. Oh, my rubber has stopped working. That's not ideal. Okay, so as the maths mark increases, the science mark increases too. So as one value goes up, so does the other. That's positive correlation. And as one value goes down, the other goes up, goes down as well. That is negative correlation. Okay, and for the final one, I'm told the graph shows the number of hours of sunshine and the amount of rain there is in millimetres in 10 villages in the north of England on a day in October. I need to, first of all, describe the correlation in the graph. So think about the line of best fit. It's going to look something like this. You just want it to go through as many points as it can. So have roughly the same amount of points above as below the line. So I've got 1, 2, 3, 4, 5, 1, 2, 3, 4. And I'm going to explain why I've ignored one of the points in a bit. So you're looking for a trend. Almost if you squint your eyes, what's the pattern that you can see? And that's how you draw the line. So this is a negative correlation because the line is going downwards. As the number of hours of sunshine decreases, the amount of rainfall increases. So this is why I've ignored this. It says, what are the coordinates of the outlier? So this here is an outlier, and an outlier is a piece of data that doesn't fit the general trend. Okay, so all of the other pieces of data follow this kind of downwards line. This is just a random piece of data sitting far apart, and I need to work out what the coordinates are. So I'm going to go along the x-axis first. So that's going to be 2. And then here it's really difficult because it's such a small graph, but that would be 1, 2, 3, 4, 5. So 1.2. It's not the best version, but you just read the X and then you read the Y. And you know that between 0 and 2, there are 10 squares. So each little square, you do 2 divided by 10, which is 0.2. So each little square is worth 0.2. And I think, if I'm correct, that it's okay, let's do it properly. So 1, 2, 3, 4, 5, 6. Yeah, 6 squares. So that's why it's 1.2. Now it says another English town has 4 millimetres of rainfall. Estimate the number of hours of sunshine it would have. So the first thing we do is draw a line of best fit, which is what I've done here. So this is my line of best fit. It's just a straight line. You use a ruler and you draw it through as many, so that you have roughly as many points below as above, and it's following the trend of data. And then to estimate using your line of best fit, so when there's 4 millimetres of rainfall, I go up to the line and then I go across. So again, this is not great on a really tiny iPad, but that would be 5.8 hours of sunshine. And that's our scatter graphs. The key thing is we just need to know what an outlier is. An outlier is literally the bit that sticks apart from all of the data. It doesn't look like it fits on the scatter graph.